Hello everyone, this video is intended to help you with your match moving work, I'm going to attempt to cover as complete an example as possible, except maybe capturing the HDRI image, which most of you guys were comfortable with. But yeah, it's going to try to cover as much of the process as possible, including also showing you visually how to do manual tracking. So first we'll take a look at an example of the final product here. So this is nowhere near perfect, but it's close to where your final piece should look like. This is 5-6 years ago. We didn't have HD cameras in the lab, but and you can see the video is a little bit grainy and there's some deinterlacing noise, but we're still able to capture fairly convincing camera motion. Alright. The footage we'll be working with today is this HD footage here. Alright, so there's quite a bit of movement. It also has some blurriness and motion blur like this. So some of your videos also had motion blur. It's 1080p, which will help us capture small detail and help us track it frame by frame. So the bigger the resolution, the better the tracker will be. It'll take longer, obviously, than 720p to track, but it'll give us a cleaner result. We're trying to track the camera motion. Alright, so the first thing we'll do is convert that into target image sequence. So I'll open up, we have After Effects here, so just drag that into it, and I'll drag it onto the timeline. Alright, and here you obviously get a chance to do any pre-processing to the video if you want. And we're just going to go here to File, Export, Add Render Queue, and in the format, I'm going to click here to change it to Targa. Now I could resize it here, 720p, but I'll just keep it 1080p for now, because I'm happy with that. Okay, click OK. And sometimes when you select Targa, it'll ask you for the format. 24 bits is fine because we don't have an alpha channel. We only have an RGB. We only need RGB images. That's fine. We don't have an alpha channel for this video. RLE compression is lossless, so you can use it if you're running out of space. But for me, that's fine. And it's faster to process this way. Pick an output folder. So I'm gonna create a folder here. So source sequence, and just a tip, don't leave any numbering in the sequence file names. So this will help the image sequence loading algorithms in both Maya and MatchMover just not confuse anything. So the only numbers that should be there would be the sequence numbering, so 0000, 0001, 0002, so on. So I'm gonna call this source video and save it. Alright, and just render it out. Then it shouldn't take too long. And we'll start seeing our sequences here. Okay, excellent. Alright, now that the sequence is done, I'm just gonna close After Effects, save on RAM, and bring up MatchMover. And don't worry that it's 2013, MatchMover hasn't changed since 2011. Alright, so these three buttons are your friends. So the first thing you're gonna do is load the sequence. So I'm gonna go to my source sequence, click the first image. My footage was captured at 29. And everything seems right. Yep. Alright. So it is 1080p. on your system, whatever you're using, your laptop or your computer, it might slow things down a little bit, but you know, it'll help your track capture more detail better. So you can play it once to fill out the cache as much as you can, but it seems okay for now. It seems to be playing back fairly smoothly for me. So right away we're just going to run the automatic tracker and see how that ends up looking like. Alright, so the 3D tracking is done, and you can see that it's fairly green throughout. Let me bring up the full interface. Yeah, it's fairly green throughout. Because it was a well-lit scene and it had a lot of decent features to capture, it didn't have a lot of problems with it. The camera solve is not perfect, but let's take a look. So I'm gonna hit the 3D view and then hit C to lock onto the captured camera and play it back. So there's a little bit of jitteriness in the 2D capture, but try to focus your attention on just the 3D when you're viewing your footage for the 3D solve. Just look at the camera movement itself. Does it look decent? Does it look acceptable in 3D view or not? Because at the end of the day, all these trackers are not going to be rendered in your scene, right? What really matters is the 3D camera movement. And if you look at the grid over here, it looks almost there. Like this is, I'd say, like 90% done. And I think over here there's going to be a little bit of camera. Yeah, the angle slips a little bit, because a lot of these good tracks up here, these points that were really good to track, are exiting the frame. So if we let it play back, you'll start seeing the camera drift a little. Did you see just that? So over here, there's a little bit of slipping on in the beginning of the footage. The grid was almost parallel to the surface of the table, and by the time we got here, it no longer aligns properly. So there's a fair bit of camera slipping because a lot of these good trackers up here left the frame. Okay. But that's all fixable, and it can all be dealt with, and that's one of also the problems that you are probably running into in your own footage. But let's say that automatic tracking doesn't completely work. I mean, you can also reference the slides, the tutorial slides, on trying to fix your automatic tracking. So the automatic tracking settings, you can open them up and try to play with these settings for a little bit. You might just end up using the automatic tracker and everything is okay. And these settings right here. Okay, yeah, so reduce sensitivity a little bit so you don't capture a lot of the noisy areas. Decrease the density just a touch, and you should have a better result overall. Okay. But let's say that automatic tracking doesn't work at all. You ended up just never really got it to work. So you're gonna have to end up using manual tracks. And the only difference between automatic tracking and manual tracks is, with automatic tracking, the computer picks the points that it thinks it should track through the image and tracks them for you. But with manual tracking, you have to pick the points and you have to put them back to where they're supposed to be throughout the footage by keyframing them. Alright, so let's take a look at how that works. So I'm just going to cancel this and delete my my auto tracks. And before we track, let's go back to the footage itself. So for a footage to be well tracked, it needs to be, first of all, well lit, to have good contrast, so we can capture features like this. For example, here, if you look at, I'm looking at the magnifier area here for good features. So areas like corners, areas that have a certain pattern that I can track, like the plugs in the wall, the sockets in the plugs on the wall, edges are not good, because I can, if I start a tracker here, and you can see it in the magnifier window here. If I start a tracker here, and tell it, okay, find this feature in the next frame, well, it could be anywhere on this edge. They all look the same. Look at the magnifier. They all look the same. So that's why I got some trackers that were moving around and they weren't sure where they're supposed to go. But the whole point of tracking is to have a point that remains on a single point in real space throughout as much of the video as possible. Right? So when I place a tracker on this socket here, it should remain on that socket for the entire video. Okay? And a lot more of that advice is here in lecture 14. So when you look back at the theory of tracking itself, how 2D tracking works, we find a tiny piece of the image, and we try to track it through the image by finding it in the next frame. But we don't search the entire image, we just search this bigger square. So this becomes our pattern area, and we're looking for it in the search area in the next frame. Okay, so let's start with an example here. So I'm just going to right click here and go back to my 2D view. And I'm going to right click here and start a new track. Alright, so let's say, for example, I want to track this pattern here, this like smiley face or whatever. So I'm going to click here, and I'm going to hold Control Alt and left click and drag. Sorry, right click and drag. Alt left click to pan. Okay, so I'm just going to zoom in a little bit more. I'm going to select it again, just to zoom in a little bit more. And actually, we can pin it. If you hit the pin button here, it'll automatically center the image onto the track, which is kind of neat. So right now I created the track on the first frame. If I scroll, there's nothing. I didn't do anything with that track yet. I didn't tell it to solve anything. I didn't tell it to track anything yet. Just placed it there. I'm going to increase the search pattern area just a tiny bit, just to make sure that I'm looking exactly for that. Okay, and I'm going to make the search area just a tiny bit bigger. It's fine if it overlaps with this a little bit, because we're searching for the entire pattern area, not parts of it, the entire thing. Okay, so with this setup, looking in the next frame, it should still find this and move the tracker a tiny bit. So if I go run forward, so I'm gonna track forward. If you look at this bar here, if you don't see any of this, the interface, just make sure that you're in full. In light, we had these three up here, and in full, we have these three up here, and also the tracking toolbar. So you can click this or hit F3. Okay, so we're gonna track it forward, see what it does, and you can see it's tracking movement here. All right, and until it finally just doesn't find that pattern anymore. So it's not very healthy. There's a lot of reds and yellows, but we'll fix that. So I'll click the tracking point and go frame by frame. So you can hit Control and then the arrow keys, and you'll be able to skip frame by frame, which I find is a lot easier than this track here. Let me make sure that I track it. All right, and let's go. So this looks right. Actually, let me pin it so we can play it back, see what happens. So this looks okay. Oh, sorry, I unpinned it. Let's pin it back. Oh, I gotta select it first. Sorry about that. Yeah, now it's pinned. Yeah, this way the camera is moving with it, but if I bring it up, it'll be easier to see. So this is what pinning does. Okay, so I'm just gonna bring it down if I can. All right. So in this part here, because it's a little blurry, it's not sure, so we're going to tell it, you know what, I know where it is, it's right here. So this will make it green when I hit F3 again, or this button here where we track forward. Alright. and then move just a little bit forward. Again, it's not sure where it went, but the track looks fine. See here, I tracked the one below it, the socket below it, but that's fine because it's really blurry, but I'm going to force it. I'm going to tell it, you know what, it's right here. I know that it's right here. Alright. If I go back a couple of frames, it's a little too red. See, the idea with the difference between red and green and so on is the amount of confidence MatchMover has in the quality of this track. So when you go in yourself and manually tell it, you know, this is fine, it becomes green. It becomes confident that this is where that socket is in the image. Alright, so I'm going to go forward. And this is really what manual tracking is mostly about, just fixing these kinks, these areas of uncertainty that MatchMover isn't sure about. If you have a tracker like this, that's, you know, you fix it a little bit and then 5 frames later you fix it again, 5 frames later you fix it again. One thing you can do is instead of going in a linear fashion like this, is go every 5 or 10 frames and place a keyframe. So let's say here, and I'm going to say here, let's go here, especially in areas where it's uncertain what's going on. Placing a keyframe would help it. So I'm just hitting with the left key here, the left mouse key, my left mouse click, and I'm just filling as much as I can. Okay, so let's get it before it jumps. And you can increase the search area. So in my footage, I zoom in a little bit, so it's okay if the search area gets bigger. Let's give one here because this is really good. I think this will track just fine. It doesn't need many keyframes, but let's put one here. And again here. I'm just going to leave the frame at about here. So this should be an end frame really. So I'm going to right click on this, set keyframe, or actually over here, I'm going to set this to be an end frame. So under status, we're going to set the keyframe to be an end. Okay, so that will tell it to just stop there when it's doing the tracking, in between tracking. Let's fix this gap here. So okay, so now the next thing we need to do is to fill in all these gaps. So track forward and backwards, which is this button right here. All right, so let's do that. Try to fill as much as we can. We're still gonna run into some areas like before, but it's a lot more reasonable than going, you know, 5 frames at a time and just fixing it 5 frames at a time, just fixing it. So it's a bit of rotoscoping, and most of the red parts are going to be of good quality now. So again, when you see this, fix it, and then run the back and forth track again. The track is mostly green and yellow, and I don't see any problems. I'm going to pin it again. Actually, there's a tiny bit here. So I'm going to confirm that it's okay. Don't worry about it. It's not red. All right. And just play it. Just do some visual inspection where you just play it yourself and see what it looks like. All right. So what happened there? Yeah, no, that's correct. Okay. that good. Let's see. And I picked the socket because it's an example that has a distinct feature, which is good, which is what you should look for, and also quite a bit of motion blur, and it also exits the frame. So if you have features like that, you know, utilize them. Don't worry that they exit the frame or they don't cover the entire footage. This bit right here needs to be covered. The quality is too low. Okay, I'll just tell it exactly where it is. When it tells you the quality is too low, it just means that MatchMover doesn't exactly know what to do with it. So just tell it, you know. Okay, so this track is over. So I'm gonna unpin here. I'm gonna reset the view. Okay, and play it back. See what the track looks like. Okay, so here's the tracker. I don't want it pinned. I just want to see what it looks like. Great. Okay, so that's the whole idea. That's the key behind manual tracking. If automatic tracking doesn't work for you, or if automatic tracking is almost there, you can add a couple of manual tracks, and it will help solidify MatchMover's understanding of your scene. So what do you want to look for? Again, the slides have really good advice here. So in the 2D tracking section, you can see examples of what makes a good feature to track. So things like corners, things like markers, like mocap markers that you see. It's the mocap markers on the face, not mocap markers in the infrared room, but mocap markers on the face. Follow exactly that same idea if it's one feature that I want to track throughout the video. You want distinct features like corners, text patterns. So in this case, we had a very clear pattern that we can follow. If you had a letter or some sort of text, you can follow that as well. Like later, we're going to do the flag because that's an easy pattern to follow. Things like corners, again. Edges are bad because you can see throughout the entire edge, it all looks the same. The same thing with solid areas. So this entire area here, if you look at the magnifier, they all have the same sort of shade and color. And if you try to track that, your tracker is going to be going back and forth the entire time and just mess with the camera understanding of your scene. So corners are good to track. So place trackers there. You know, this is a good pattern to track. Anything with good contrast that you know it is unique and within the search area is going to be easy to find. So I'm just going to go in here and add a couple more tracks, and hopefully I'll get some results soon to share with you. But before we do that, I'm just going to go back to the socket itself because it enters the frame again. So we're going to deal with that. Because if you can bring a tracker again, instead of starting a new track, it will help MatchMover understand the depth in the scene if it knows that it's the same point in space again, right? Instead of it trying to figure out, well, where is this point in the 3D scene? Well, it is the same one that you tracked before. It just left the frame. So I'm gonna insert a keyframe. In the first instance, it enters the frame right there. So again, I insert it by we're not inserting any track, we're just going to click in here. First you got to select the track itself, and then I'm going to insert it. Okay, and you'll find that again there's no frames in between. That's fine. I'm going to make sure that the one that I'm standing on is set to begin. All right, and do the same thing over again. So we're just going to play it. I'm going to try to track it from here and see how it goes. That's not bad, actually. That's fairly accurate. Let me pin it And so I'm going to pick the track, zoom in, play it forward. That looks very accurate. Yeah. So there's no manual work here except to go to the uncertain areas and just give it more confidence. So I'm just gonna move it here slightly a little bit, go to the frame before it, and also move it just a tiny bit, and all becomes green again. So let's go here. No, you're fine. Let's go here. And it's okay if you have these little jitters, because that captures, again, what happens with the camera. Because if that happened with the camera itself, then you want to capture that. So, let's click there, and give it some confidence here, and right here. Okay, so let's try that, see how it goes. Yay, no more uncertain red areas. Okay. And one of the things, the sure things that tells, that gives your manual tracks more confidence in the MatchMover algorithm is this tick right here that says it's a hard track. It's not an automated track. It's not something that MatchMover is guessing. It's something that the user knows to be true. Like, this is a true tracking of that object in real space. All right. So when that's checked, that means that this track is correct, no matter how uncomfortable MatchMover is with it. But if you eliminate the red areas, it'll help solve the camera a lot better. Okay. So we're gonna carry that forward, see where it goes with that. Great, we reached the end of the footage. So this was an example of something that exited the frame and entered again. You don't want to, start a new track just for that. Okay, so you would do another one for this one here. That's not repetitive. That would actually help it with the depth computation. So if you do another one here with the same idea, and also maybe the corners. So the corners will also have a unique pattern. So I'm going to do just that, try to find important areas. So I'll place a tracker. Let's do one of the corners. Actually, let's do another one here. So this not on the same depth level as this. And in general, you don't need that many tracks. You only need about, I'd say 12 is a good number. Yeah, 12 and higher is a good number. So, and 12 that not all lie on the same plane, that capture a little bit of depth, would be good. So, I'm gonna pick let's pick a corner here. So, let's go, let's say this one here. Or this one actually. Okay, I'm gonna zoom in, make sure that the search area is fairly unique. Yeah, that's right. That's good. This actually what I need. Just make a tiny bit bigger. If you make it too big like this, like someone suggested, why not? If you look at the first track, why not track the entire, the entire socket? You think, okay, well, that would be a good idea, and it's okay. You can do that, but it'll take longer for the tracker to work. It'll take longer for the solver to understand it. It's easier to do it for a smaller number of pixels, especially when you have that many frames. You're talking about hundreds of frames, and also the more tracks you have, the more correct trackers you have, the easier the solve will be. The 3D camera solve will be. I know I'm talking a little bit too much about tracking here, but it's all these just concepts that are feedback to some of the problems that you guys were running into. So hopefully this will improve your understanding of how tracking works. Alright, So I'll pause the video, I'll add a few more trackers, and quickly keyframe them and start to get our camera solve ready. Alright, so I've added a few more trackers here. I have 7 in total, and I've went through and made sure that they track the exact point that I'm trying to track throughout the video. I try to pick points that are available for the entire duration of what I'm trying to track. So in this case I have about 10 seconds. So on the ship I have two trackers here. One of them is tracking the cannon, and the other one is tracking this lamppost. And the top of the lantern here is a good reference because it stays there throughout the video. A lot of stuff comes in and out of the frame, but these two corners here are good. The socket that we started with is fairly decent, but because it leaves the frame, it causes a little bit of issues towards the middle here. But we have some good depth markers here, here, and here to differentiate them from the wall. So I'm trying to treat the wall as sort of reference Z depth. So let's give it a try. Let's see what the 3D solve looks like. I only have 7 points so far, and let's see if we can get a solve out of this. So we'll go 3D tracking, solve for camera. Alright. So as you can see, it's a lot faster than the automatic solver, which take into account like hundreds of trackers. But let's take a look. So I'm going to hit 3D, hit C to lock onto the camera, and play it back. You can see the markers, tiny little markers there, and here's the grid. So you can see from just a few markers, you're getting a fairly high quality result. This is close to the automatic one, especially considering the fact that a lot of we only have 7 markers in the scene, and half of them are leaving the frame. So considering that you don't have a lot of information to work with, it's still good. You see that example here where it jumps up. This happens right when this one here leaves the frame. So what you want to do is find some other reference that links these two events together. So let's say, so what I mean by that is this jump right here, this error in the camera calculation, is because this cone is no longer being considered in the calculation. So what you want is to track something other than these two. It's to track something that is constant between here and the spot here. So what I would do is I would start tracking these two corners, and it doesn't have to be tracked throughout the entire video. That would be ideal, but at least get some tracking from here up till here. So that way you're patching that spot of missing information, and you won't get that sudden jump. Alright, let's view the rest of it. It looks fairly sturdy, actually. Okay, cool. So once you get that, actually let me go in and add the trackers real quick. I'm gonna go back to 2D mode. I'm gonna come here and add. It would be really good to add more trackers here because these have like big lengths. And 1 second, I'm gonna turn off that. Alright, so I'm gonna add a tracker here, over here, and set it to begin. Let's just try to patch this part. Oh, I have another tracker here as well, so I'll just put it here. Okay, let's get this corner, and set this to begin, and let's go. Can we track it till the end? I think we can track until the end. Yep, they stay inside the frame. Let's check. Yeah, this part here is fine. Up to about here. Up to about here. So I'm gonna add. This is track 8. So 8, I think, is this one. I'm gonna set this to end. And track 9 is gonna end about here. And that's gonna end. And actually track 8 should be a little bit more on the corner. Okay, so let's track these two, see what we can get. So I'll just go to the middle here and track back and forth. Okay, so that one, track 8 is okay. Just a few patches here. Okay, track 8, okay. So, that looks good. Let's go 4. I'm hitting F4 to track back and forth. Okay, good. For track 9, let's go back and forth. See, I have it pinned. So let's pick track 9. Okay. F4. Let's see what it does. Quality's too low. Let's see what it does. Pin it, please. Yep. Okay. So track 9 starts a little bit off. I think that's why. So that's the corner there. Track 9. Okay. Here. Let's solve. Okay, let's go to these areas. It looks good. Oh, whoa. Okay. It's because of all that motion blur. Let's just set it to here. Let's go back and forth. See what it does. Okay. So this part is fine. This part is really bad. Okay. This part needs fixing. See, even if it's green or yellow, you need to go and check it, make sure that it actually is tracking the points that you're trying to track. And green points that are incorrect are worse than red, because that means that the solver thinks that this is absolutely the right place for where that tracker should be, and it will definitely make your camera solve incorrect. Okay, that looks alright. Here's another example of that fix. I think just a little bit. Okay. Yep. Now if I zoom out a bit, these two should fairly line up. I think tracker 8 needs a little bit of adjustment here. So it goes corner, 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 and then it skids a little bit here. These keyframes are not good, so I'm just going to shift, select this area here, and then backspace. Don't hit delete, hit backspace. Alright, and then shift, right click to deselect. And I'm just going to set a new keyframe here to this area and retrack it. Okay, let's go back just a couple of frames. That looks good. F4. almost done here. This stuff needs to be fixed, so go down, bring it back down here. Let's check it again. See, edges are always trouble, so you always want to find corners. But because of the motion blur, everything just ends up looking the same. Okay. And then it leaves the frame. So, okay. So with these two there, they line up. They line up okay. What I'm gonna do is also, so I added these two to help the camera solve. What I'll also do is set up the coordinate system. Okay, that will also help us quite a bit. So first, I'm gonna go to 3DC, new coordinate system, and in here for the y-axis, ideally you would have a big y-axis, like let's say from this point here to a track point over here. That would be perfect, because the more the camera moves, the better you capture that y-axis. But these two will do for now. It'll be okay. So let's go. So the y-axis goes from track 6 to track 4. So I'm gonna pick the first axis as y. It goes through 2 points, track 4, track 6 to track 4. And for our second axis, we're gonna pick. I don't have any. I want this direction to be my x-axis, and z is obviously the depth. I don't have any x-axis points that'll line up. Again, these cubicles would be perfect, but I don't have any points right now. But what we can do is we can set the z-axis to be perpendicular to these 3 points. So I'm going to say z normal to 3 points, and I'm going to pick tracks 1, 4, and 6. Okay, so 1, 4, and 6. And if the z-axis turns out to be flipped, we'll just have to replace one of these two. So let's just try it out, see what happens. So we gotta view this in 3D, okay, and hit C so you can lock the camera onto it. Now I'm gonna play it back. All right, so you see the z-axis over there? It's facing the other way, so what I'll do is I'll just switch these two. Switch any two, it doesn't matter which. So let's say this one here becomes 1 and this one becomes 4. And apply it. And the z-axis is fixed. Okay. I haven't done the camera resolve yet. I'm just setting up the coordinate system to help the camera resolve. Another thing I want to do is I want to set up a point relation. So I'm going to right click on the point relations folder. New relation. Okay, and I'm gonna say that track 1, 4, 6, track 5, and 8 and 9, the ones that we put in the middle, they all lie on the same plane, and that will help the camera solve quite a bit, actually, especially with that jump in the middle, without adding more trackers or adding more detail in the scene. So I'm gonna pick 1, 4. I'm just holding control here. So 1, 4, 6, and 5. It doesn't matter the order. The order really doesn't matter. Let's see, 8 and 9. So I'm gonna add these tracks to the left side. I'm gonna say that they all share the z-axis. Share the z value. So they all lie on the same plane. And I'm going to set that plane to be 0. And I'm going to call that plane 0. So if I play back, you'll find a nifty little plane that tries to stick to these points throughout the video. And I haven't done camera resolve yet, but that plane should help. You know, fixing that plane and telling the solver that these points lie on the same plane is going to help it figure out the 3D space better. And again, this would be a lot nicer with these giant cubicles, relatively giant cubicles, because you have big spaces and less room for error. But let's see if this actually improves our camera solve. So I'll go here and go to 3D tracking, solve for camera. Actually, before we do that, I'm going to go to the coordinate system and set the distance. So I'm going to say from 4 to 6, it's about 10 centimeters. So I'm going to set it to 100 units. I could set it to 10, but it ends up being really small for what I want to do. So 100 is fine. Or let's set it to 1. See what that looks like. Apply coordinate system. Don't disable your relations. That's fine. Okay. Yeah, that looks better. Okay, I can see the cones a little better now. Yeah, so let's go 3D tracking, solve for camera. Alright, and don't forget to save your MatchMover file. That's fine if you get that warning. You're trying to give the system as much information as you can. Sometimes it says it's not sure, but it's better to have the information than not have it at all. Alright, so I'm gonna play it. I know the video is a little choppy in this capture, but I'm just gonna visually inspect. It just looks like everything is okay. Let's see the part that we try to fix right here. If there's still a jump. So you can look at you can see the ground plane there. Okay, because that's where we set up our coordinate system, and it looks fairly stable if you look at it. It wiggles a little bit, it wobbles a little bit, you know, and with more tracking points you're gonna solve that. But I think this is ready to go to the next step to try to do rendering. Okay, so this example was to show you how to do manual tracking. You don't need that many points. You usually have to look just for quality points that last for as long as possible. You can add some relations in coordinate system to help you define the scene better and help MatchMover understand the 3D aspects of your 2D images. All right. So in the next video, we're going to take a look at rendering and lighting setup.